Good day, ladies and gentlemen. I'm Rihanna Judy S. Alsaman from Emiliano Triaterona Memorial National Integrated High School. I'm here to present my research entitled The Molluscicidal Activity of Papaya Seed Ethanolic Extract Against Golden Apple Snail. Have you ever seen those small pink eggs all over the grass whenever it rains? Those are the eggs of golden apple snails. According to Joshi and others in 2017, these snails are actually major pests in rice fields and have caused immense financial losses in the Philippines. In an attempt to control the populations of golden apple snails, there has been a rampant use of chemical molluscicides which affects both farmers' health and also harms the environment. This led to research on potential biomolluscicides that are safer for people and the environment. Several studies have pointed to papaya as a potential biomolluscicide, including its seeds, which are considered as inedible wastes. This led to an investigation of the molluscicidal activity of papaya seed ethanolic extract against golden apple snails. These are the questions this study seeks to answer. First, what is the mortality rate of golden apple snail treated with different concentrations of papaya ethanolic seed extract when exposed for? Second, what are the LC50 and LC90 of papaya ethanolic seed extract against golden apple snail? Third, is there a significant difference between the mortality rates of golden apple snail and treatment concentrations of? These are the null and alternative hypotheses. To answer these questions, the researcher conducted a molluscicidal assay where samples of snails were immersed in different concentrations for 72 hours at 24-hour intervals. Mortality rates were calculated and then statistically analyzed. This figure shows the mortality rate of golden apple snails at all exposure times at different concentrations. One-way ANOVA proved that there is a significant difference between the mortality rates of golden apple snail in different concentrations of papaya seed ethanolic extract. Of the first 24 hours of exposure, the mortality rate of the positive control is significantly higher than all other treatments. At 48 hours, the mortality rate of concentration 400 ppm is significantly higher than the mortality rates of 200 ppm, 100 ppm, and the negative control. At 72 hours, the mortality rates between different ppm concentrations are significantly different from each other. At all exposures, positive control always has significantly higher mortality rate than other treatments. But at 72 hours, its significant difference to 400 ppm has decreased. Based on the derived results, it can be concluded that papaya ethanolic seed extract exhibits molluscicidal activity against golden apple snail, where the mortality rate increases as the concentration increases. This is in line with a study conducted by Jaiswal and Singh in 2008, where it is evident that an increase in the concentration of extract caused a marked mortality in snails. The extract has the lowest LC50 of 260 ppm and LC90 of 505 ppm at 72-hour exposure. This is also in line with the study by Jaiswal and Singh in 2008, where the LC50 of the papaya seed ethanolic extract decreased the longer the snails were exposed to the extract.